Alright guys, we're going to solve systems of equations in two variables. You should have done all of this before. It should be a good review. Hopefully once we start this video you'll recognize it and won't have any problem whatsoever. So let's try and see. Alright, first there's three methods we're going to do. The first method is graphically, and I'll be honest, I'm going to show you on your calculator how to do this method tomorrow on the calculator instead of having to go give you graph paper and do it by hand. But basically what we're going to do is we're going to graph each equation. If you can see the graph right here, I'm kind of moving it around. The first equation is red, the second equation is green. Basically what you're looking for is where they intersect. The intersection point is the point that works in both equations, as a solution to both equations. Every point on each line is a solution to that equation. So the solution to the system would be 2, -3, because that point is on both lines. In other words, it solves both equations. You could plug it back in if you want to check, but I promise you it will work. All right, you have three things that could happen when you graph two equations. First of all is what we just saw. They're going to intersect in one point, which means there's exactly one solution. They may be parallel, may not intersect at all, and if that's true, there are no solutions. Or, even though it looks like there's just one line, what happens here is that the two lines are identical or they're the same line, which means they have every point in common, so it's infinite solutions. Now, 4 words you got to know. This may be the hardest part of this lesson. You got to know these words, so make sure you write these down. Consistent means there's at least one solution, at least, which means there may be one or maybe infinite. Inconsistent means there's no solutions whatsoever. That's parallel. Dependent means there's infinite. That was the last picture we saw right here. And independent means there's exactly one. So that's the first one we saw. So that very first picture, we would say that's consistent, independent. The second picture, we would say that's inconsistent. And the third picture, we would say that is consistent and dependent. Okay, the next method we're going to use is called substitution, and this method you should have seen before, no big deal. But only use it if you have one variable that has a 1 as a coefficient. In this case, the first equation, both of these have a 1 as a coefficient, or 1 and -1. So I'm going to move the y to the other side, make it say positive y plus 5. And I'm going to substitute it into the second equation where the x is. So I'm going to take out the x. I'm going to put a y plus 5 where the x was, plus y equals 1. And I'm just going to solve that. So distribute the 2y to 2. Make that look like that. Now I'm going to do two things. I'm going to add the 2y and the 1y, which is 3y. I'm going to move the 10 to the other side, make it -9, and divide by 3. So I'll get y equals -3. Now that's your y. Now one beautiful thing about substitution is you can find the x very easily by just plugging it back in. So I'm going to put a -3 where this y was. -3 plus 5 is 2, which means x is 2. So you can write your answer like this, 2 and -3. And because there's one solution, we would say that that one is consistent and independent. And the last method today is called elimination method. To be honest, it's my favorite one. I use it all, if I just see this I pretty much do this. What you need to do here is you got to eliminate one of your variables. So you got to multiply one or both equations by something to make one of your variables disappear or become opposites. So what I'm going to do is I'm going to multiply this top equation by 5 and the bottom one by 4, because what that would give me with my x's, it would give me a 20x here. Now my bottom equation will give me a -20x. Now you have to multiply the whole equation by 5 though. So I'm going to make it 15 there, 55 over here. Same thing on the bottom, multiply by 4, make that an 8y and a 60. And I'm going to add those together. That's gone. That gives me 23y over here. Over here I get 115. If I divide both sides by 23, I get 5. Now, I still need to get my x, so you can take your 5 and plug it in anywhere there you want to. I'm going to pick the first one, which gives me 4x. If I put the 5 right here for that y, that gives me 15 equals 11. Move the 15 over, it's -4, so it gives me x is -1. So my answer is -1, 5. And because there's one answer, it would also be consistent and independent. And guys, those are the three methods. The only three methods we're going to see. That should have been all review for you. And we'll work on these in class tomorrow, and I will show you how to do the first method on the calculator, and we should be rolling after that. So see you then.